Dan Kalish, and this is our free mini-series, which we are putting on in conjunction with our wonderful lab partners, Diagnostic Solutions Lab, who I've known for like over 30 years, just to say that. The founders of that lab. In fact, I walked into a room at a conference 5-6 years ago, and David was there and Tony was there. I looked around the room, I was like, whoa, we are like the old guys in the room now. Like we used to be young people when we met, and here we are 30 years later, still kicking, still doing functional medicine, and so excited to be here and to have a new audience for us old folks to talk to. And so cool. Anyways, I just got off the phone earlier today with Patricia, who's a nurse practitioner that I've known. She's 79 years old and she's still practicing. So this stuff just goes on forever. And we are here basically as a generational handoff. We want you, new people who are in your first 5-10 years of doing this work, to start to take it up and start to use these labs, these amazing tools. And so the goal between Diagnostic Solutions and Kalish Institute here is to get you all the information that you need so you can start to order labs, start to get people better. And super excited to even have you on this call so you can start to become aware of all this work that is out there. And for those of you that are brand new, many of you are, I'm Dr. Dan Kalish. I've been in practice for over 30 years. At the Kalish Institute, we've trained thousands and thousands of practitioners. I've worked with Mayo Clinic. I've partnered with some of the best scientists in the field to learn this work, and I'm here now to pass that work on to you all, as I said, in this generational exchange. Time for you all to grab the baton and let the folks that have been doing this for 30 years to take a little break. Organic Acids Protocol Design Bootcamp, that is coming up very quickly. It's October 7th. So if you're interested in this topic, scan that QR code, get 20% off. And in this class, Interpreting Organic Acids class with Diagnostic Solutions that we're doing together, you're going to order labs from Diagnostic Solutions, you're going to send them in, and we're going to review them in class and show you all the protocols. There's also a very robust online curriculum to teach you how to interpret the labs, and then the live Q&A calls so you can actually apply that information in real time. So if you're interested in organic acids testing and you want to get better at it, this is a great entry-level course for you to do. And for those of you that are asking, a couple of people are asking, yes, you can do it if you're a nurse practitioner, chiropractor, medical doctor, health coach, chiropractor, acupuncturist. We get all kinds of folks taking this type of course, and sometimes for their own personal interest, and more often because they have a busy practice and they want to incorporate this kind of testing. You know, and how can I say this? I don't want to be rude to anybody on the call, but when my first 20 years of practice, I thought organic acids was optional and that you just did organic acids if you couldn't figure out all the problems that the patient had. And that's honestly the way that I was taught, was that, oh yeah, you do organic acids when you don't know what to do because all your other stuff isn't working. And in the last 15 years or so, I've run organic acids tests on every single one of my patients, and every single time that I've run that test, I've been thankful and glad. The patient has been thankful and glad. You will never order this test without gratitude coming from your patient towards you, because you're always going to find things to work on. It's a profound test, and don't save it for just the tough cases. Do this as a screening test on every new patient. Use this as a screening test on every new patient, okay? And then I'll tell you one of the sort of inner secrets about this test is when you do your follow-up testing 6 months later, you're going to learn even more about that person's cell physiology than you did on the first test. So this is one of those types of tests where the follow-up test, the second test that you do in the series, is going to be like mind-blowing because you get to see all the changes that you've made and the next things that you need to work on. I can't imagine now, and I would not talk to a patient who is new without having this test done. You know, I mean, it's that important. This is like a mission critical thing. So today we're going to focus on just one narrow aspect of this test, really just 2 or 3 of the sections, and there's many sections to the lab. And the way the class today is structured is I'm going to go through these slides rather quickly because I want to save at least 20-30 minutes at the end to review labs and show you how we're going to apply this, okay? And so I'm not going to talk through every slide. They're here if you if you see a slide, you're like, well, that's a cool slide, take your phone out and take a picture of it, okay? Because we're going to go through kind of fast and try to cover the big picture concepts. And we're really looking at the central problem, which is that people eat too much food, especially sugar and carbs, and we have to store that excess calorie surplus somewhere. People don't have enough muscle mass to buffer against the times when they're eating too much food. And there's a sweeping global problem called environmental toxins, which are impacting all of us. And environmental toxin exposure damages your mitochondrial enzymes, and that creates high markers on these organic acids profiles. You see high markers, you know there's a damaged enzyme. Something's damaging it. It could be a nutritional deficiency, it could be a toxin, it could be genetics. There's a lot of different reasons, but a primary reason, a main reason, the top three, one of the top three reasons why you see mitochondrial enzymes damaged on organic acids is because of environmental toxins. So of course, you need to look at detoxification as well. Okay, and then why is this related to patients that we're working with? Because this is the center point that heart disease, diabetes, obesity, metabolic syndrome revolve around. This is what we're trying to look at, the early warning signs of heart disease, metabolic syndrome, obesity, diabetes, and try to address them before they become a major problem. And it's all about insulin, right? It's insulin driving lipid dysfunction. And so managing insulin is the key to all of this. I forgot to mention, we're going to do questions at the end. So you have questions, type them in, and I'll cover as many as I can at the end. And you can type in questions as we go. I'll try to answer some as we go, but we'll for sure do have plenty of time for questions at the end, okay? So insulin drives lipid dysfunction, and we need to look at some pathways here. If you learn the pathways, you're gonna understand the labs, because on the lab report, you're gonna see succinic acid. That's from this succinate enzyme, succinate dehydrogenase enzyme. On the lab report, you're gonna see all these things show up, okay? You're gonna see pyruvate, you're gonna see carnitine, you're gonna see all these markers that are directly related to these pathways. So you understand the pathways, then you can understand the lab. And what we're talking about in the biggest picture view possible is that we have this process called glycolysis, which we use to break down sugar or carbs into pyruvate. There's another pathway over here that goes to lactate, of course, but this is simplified. So that pyruvate then enters into the mitochondria and we make energy out of it, right? That's a pretty important process. There's an equally important process, I would say more important, where we take fatty acids, convert them into fatty acetyl-CoA, bring them into the mitochondria and burn them up for energy. Why do I say that one's more important? Because everybody talks about insulin resistance and nobody's paying attention to beta-oxidation. So it's kind of more important that you know about it, because you're going to hear endless lectures on insulin resistance, but you're not going to see too many talks. People talk a lot about beta oxidation, so we're going to cover that today. And here's your electron transport chain where you're making your energy. Okay, so we're measuring all the different aspects of this. We're measuring pyruvate and lactate. We're measuring the different fatty acid metabolites. We'll look at those. We're measuring to see how well is beta oxidation working and how well is glycolysis working. And these problems will develop before the person has diabetes. These problems will develop before the person has advanced heart disease. These are the early warning signs that there's a problem with your lipids, there's a problem with your insulin and how that's being handled. And if we can intervene and correct problems in the electron transport chain or with glycolysis or beta oxidation, you can get people super healthy. And that's kind of what the goal is for today, to understand how that works. So we can make energy both with and without oxygen. That turns out to be kind of important. If you're making it without oxygen, and just as a simple example, I know this is like the stupidest thing, but I'm going to tell you, I do this every day. When I'm going to work, there's like a flight and a half of stairs that I have to go up to get to my office. And 9 times out of 10, I take a deep breath in at the bottom of the stairs and I run up as fast as I can because I want to get my fast twitch muscle fibers working every day, you know? And I'm always amazed that I can run up the flight of stairs without breathing because I'm holding my breath. It's incredible. You can make energy without oxygen. That's anaerobic metabolism. And of course, when you're exercising, hard, that's what happens. When you're doing that, you also produce a lot of lactic acid, which is both good and bad. Lactic acid, or lactate, is the preferred fuel supply. I'm going to say this again. Lactate, or lactic acid, is the preferred fuel supply for heart and brain. So lactic acid is not what we learned in school, this waste product that just messes you up and makes your muscles sore. Lactic acid is the preferred fuel supply for the heart and the brain, and that's based on the work of Dr. George Brooks at Berkeley. He's been studying lactic acid for decades and is a sort of preeminent scientist in that area. So anyways, anaerobic metabolism, very important that we can make energy without oxygen, and of course, equally important that aerobic metabolism is working, which is in your mitochondria, and that's what we're doing with oxygen. So that's the important distinction. In the mitochondria, with oxygen, oxygen's required. Outside the mitochondria and the cytosol, we're making energy also with anaerobic metabolism. You kind of got to know that because that's going to come up as a super important part of all this stuff. And here. So metabolic syndrome, right? You think about high triglycerides plus low HDL and these small dense LDLs. And that promotes inflammation and plaque formation, screws up your arteries, increases your risk of having a heart attack. So there's a strong relationship, a direct relationship between what's happening with your lipids and what's happening with your insulin. And all this is because we are making these fats based on our response to what we're eating and how much we're exercising and all this kind of stuff. So that's pretty important to think about. And so when you're thinking about how to reset all this, a lot of this is happening in your liver. In fact, this diagram here, this is all hepatocytes. So this is all liver cells. This is where what's happening. You're making your LDLs, right? HDLs, they're being produced in here in your liver cells and then being dumped out. Okay. So your liver has a lot of control over what's happening here. If your liver gets a ton of sugar or carbs, it has to do something with it. And it's going to convert it into these potentially dangerous compounds in our body. And then if we do that too much, then we can develop insulin resistance. Now we are not processing insulin well enough because we've eaten too much food so many times that that insulin response is getting wonky, and that is not great. And then patients experience depression and fatigue and brain fog. They have cognitive and emotional effects, but it's all coming from metabolic dysfunction for a lot of the people that we're working with. It's not a surprise if you look at how people eat. Pain and inflammation then are common symptoms because when you got all this stuff going with an insulin problem, that generates something called oxidative stress. In fact, when you look at the labs, there are lab markers that are completely overlapped in terms of, is this an oxidative stress marker or is this a marker that's related to insulin processing? There's a complete overlap between insulin resistance and problems with insulin and oxidative stress. And that's another reason why insulin resistance type problems have a really negative effect on your heart, because if you have, and on your blood sugar and on your brain, because you have a lot of oxidative stress that causes a lot of inflammation, that makes us depressed, that makes us achy, that causes problems with your blood vessels getting damaged, puts you at higher risk of cancer. All these different chronic degenerative conditions get worse the more oxidative stress that you have, and the more insulin resistant you are, the more oxidative stress you have. So diet does all of that. And that's why so many people are so sick right now. So you can test for all this. And we're just looking at like 2 or 3 sections of the test now, okay? There's a whole realm of testing in this one lab, but we're just gonna focus in on the parts that are most important that are related to metabolic dysfunction, because we don't really have time to go over the whole thing. And the 2 things we're gonna talk the most about are beta-oxidation and let's see, and this whole pyruvate and lactate thing, okay? Those are the 2 things that you wanna kind of try to remember from today. So beta-oxidation is the activation of fatty acids. This is us getting fat throughout the body and then pulling it into the mitochondria, transporting it, and then pulling it into the mitochondria where we burn it up for fuel, burn it up for energy. While we're all just sitting around, listening to a lecture, having, a conversation with somebody, 80 well, people argue about this, but somewhere between 60, 70%, maybe as much as 80% of your energy is coming from beta oxidation. Obviously, when you start to exercise, that changes dramatically. But at rest, most of what your heart is beating on, most of what your brain is thinking on, most of the ATP is coming from beta oxidation. And then exercise changes all that. So it's a very important energy source that we burn fat effectively, very important. And you can measure beta oxidation directly on this test. And it has to do with carnitine and the carnitine shuttle. So carnitine is a nutrient here that it's a transporter. It's a mechanism that transports the fat. And there's a central problem that carnitine has in terms of getting the body has really, in terms of getting the fat from the cytosol into the mitochondria. It's that when that first molecule here, you can see the palmitoyl-CoA that gets formed, it's just huge. It's too big to get across the membrane into the mitochondria. It's just physically too big. So your body has to cleave it, cram on a carnitine. You see how much smaller the carnitine thing is? And then that can get in to the mitochondria. So if you do not have carnitine, you cannot pull fat into the mitochondria. There's one kind of fat that you can pull across the mitochondrial membrane. I'll ask that as a quiz question. Anybody know the answer to that? That's a tough one. Who knows what kind of fat you don't need carnitine for? You put the lime in the coconut oil, right? It's a medium chain fat. It goes right in. But I mean, we're not living on coconut oil, so it's not realistic to really think about. So here again, we have the cytosol, and then in the green is the mitochondria. Richard Lord made this diagram just for me because he could tell I didn't understand what he was talking about. This was like 15 years ago. And so he created this whole diagram just for me. And he's like, let me explain this to you, Dad. So here I am. I'm explaining it to you now. Okay. And by the way, Dr. Richard Lord, who I worked with for a dozen years or so, is the founder of organic acids. He's the first scientist in integrative medicine to run organic acids testing a gazillion years ago. Okay. He's the OG of organic acids testing and a very close colleague of mine. Okay, so here's the cytosol, and you got this problem. You got this fat. In this case, we're calling it palmitic fat or palmitate. They got to get that fat into the mitochondria so you can make energy out of it. This is 60, 70% of the energy that your body needs. This is what your brain is running on. This is what your heart is running on. You don't want your heart to stop beating. This is an important thing. You can't fit it in because this damn thing is so big. So you have to cram on a carnitine, cleave it, cram on a carnitine, and then that thing can get in through that membrane. It can go through this protein into that membrane, and now it's inside the mitochondria in the green part. Now your body breaks it down for energy. That carnitine molecule doesn't sit around. It goes back out and grabs another fatty acid and brings it back, and it goes back and forth like that, like billions of times a second in every cell. I looked this up once. I don't know, it's something like 4.3 billion times per second or per minute. I can't remember in a brain cell. This happens really fast and a lot. And so if you don't have enough carnitine, this whole thing just shuts down. And you're measuring for this on a functional medicine test called organic acids. You're measuring to see, is carnitine working or not? This is a very, very important process for your body because burning fat is very, very important. And you don't have to be an athlete to want to burn fat. You don't have to, be overweight to want to burn fat. If you just want to have a healthy heart and live a long time, you got to be able to burn fat. So you also want to think about coenzymes. And coenzymes are the organic non-protein portion of an enzyme, because we're going to talk a lot about enzymes here. Enzymes are things that are helping move along the metabolism. And the coenzymes that activate and make those enzymes work, for the purposes of today's talk, that we're gonna focus on are the B vitamins. So you think of the enzyme as just sitting there, it can't really do that much, but the coenzyme of the B vitamin activates it and makes things happen. Okay, and if you don't have the B vitamin, then the enzyme is not fully functional. And we can measure B vitamins directly on organic acids testing. So you can see if you have the coenzymes you need to run all these metabolic pathways. And more often than not, it's a B vitamin deficiency that's the problem. It's that whole lock and key thing. Remember, we all learned this in school. You got the enzyme, but without the coenzyme, it's not going to work, And it's not like a equally yoked, or it's not an imbalanced situation. So you think about like coenzyme, we think about like a co-pilot. I was just on a plane recently, and there was a pilot, and there was a co-pilot. And we had a little argument in our family about which one was a co-pilot and which one was a pilot. But I was like, hey, the pilot always sits on the left. I've seen enough action movies to know that that's true. Anyway, but then we're all thinking like the co-pilot, yeah, I don't know, like they're kind of expendable. They're not as important. I mean, if the pilot had a heart attack, I'd be really worried. The co-pilot, something happened, I don't know. I'd be okay with that. So we don't think of co-pilot and pilot. When you learn about coenzymes, you're thinking, oh, that's not as important. It's essentially important. It's as important. So let's just think of them as both pilots. There's no co-pilot in this situation. The coenzyme, it's not like it's less important than the enzyme. The enzyme won't work if you don't have the coenzyme. So that elevates your B vitamins to the highest status possible for all metabolic functions. For preventing heart disease, cancer, diabetes, B vitamins are at the highest level possible. The problem is that nobody's making money off of selling you guys B vitamins because B vitamins have been around for a long time. I mean, look at when they were discovered, you know, like 50, 60, 80, 100 years ago. It goes back a long time. They found that first B1 a while ago. And so everybody has B vitamins. Every company has them. They're not really that interesting. And nobody talks about them, but they're like the most important central part of all of these metabolic functions that we're talking about. But there's no B vitamin advocates out there except for me. I'm just saying, hey, this is like the most mission critical part of this whole thing. It's the coenzyme where things really matter. Now, the enzymes are important to repair and get working, but the coenzyme is going to be more often missed, okay? And so that in mind, we're going to look at the testing when we look at the labs, and I'll show you how to identify which B vitamin is deficient. It's not that hard. It's pretty clear on the test. Okay, so that's beta oxidation. Now we're going to talk about glycolysis for a minute, and then we're going to get into labs. So so glycolysis is blown up right here, and here's our glucose being split, a 6-carbon molecule into 3-carbon pyruvates. When you're making energy and you're not breathing too hard, it's going to go through this enzyme called pyruvate dehydrogenase into acetyl-CoA, and then you're going to make energy out of it. The alternate pathway, if you're going anaerobic, you're breathing really hard, like me running up a flight of stairs, is to make lactate. Lactate is good. Lactate is good for you. Lactate is the preferred fuel supply for the brain and heart. Lactate got a bad name in all of our biochemistry classes. We all learned that lactate was bad. That's not true. The science has moved beyond that. So here's the actual mechanism, and these are the solutions. Pyruvate should convert to acetyl-CoA. If pyruvate is high, okay, then you're going to recommend thiamine or B1, lipoic acid, pantothenic acid, B2, and B3. Now that would take a while to recommend each one of those things, and it would be like 4 bottles of stuff. So what we generally do to make it easy is B complex plus some lipoic acid. B complex plus lipoic acid. That'll get this enzyme working. These are the coenzymes. But this enzyme is not going to convert pyruvate into acetyl-CoA if you don't have the coenzymes on board. It's not going to work. So you see high pyruvate, you know immediately this person needs these B vitamins and lipoic acid. Why? To activate that enzyme, to unlock that key. That enzyme's crammed up, it's blocked, it's like a roadblock, it's like a traffic jam. If you've ever been in Los Angeles during a traffic jam, there's like a traffic jam right here, right? Things aren't flowing through. You're not making ATP from glycolysis. Pyruvate is high. You want to lower that pyruvate. This is your roadmap to fixing it, these nutrients here. B complex and lipoic acid, just got to get the dosing right. We'll go over that in a minute. Okay, so here's a schematic of the whole thing. Carbohydrate metabolism. Here's our pyruvate and lactate. You see those? Those are the markers we're measuring. And then beta oxidation, the markers that we're looking at. For the sake of brevity, there's a lot of them on this test, but adipate, suberate, and ethylmalonate, those are 3 key markers. If they're high, you don't have enough carnitine to burn fat. If they're high, you don't have enough carnitine to burn fat. Okay, remember when I saw you that diagram where carnitine is this shuttle? If these markers are high, it means there's not enough carnitine to make that whole beta oxidation pathway work, and that's extra bad because then you can't burn fat. And what happens? People get fat, they're overweight, They get tired because they can't burn fat for fuel, and they're at much higher risk for problems like cardiovascular disease, diabetes, obesity, fatigue, brain fog, all of these problems. Same if you have a problem here. If you have a choke point here, you don't have enough pyruvate and lactate. If you have too much pyruvate and lactate, it means that there's no flow through here. The traffic jam is right here. Okay, and what's the solution to that traffic jam? We just looked at it, the B vitamins and lipoic acid. And each one of these is a marker on the test. So you're measuring citrate or citric acid, malate or malic acid. You're measuring adipate or adipic acid. Those are the same things, right? Lactate or lactic acid. Different lab companies represent them differently. You have to learn how to translate that. Ethyl malonate is the same thing as ethylmalonic acid. And you're not going to eat your way out of this. You're not going to eat your way out of this. Diet's super important, but when you get these enzymes that are really screwed up, here are the different supplement solutions that we're going to go through in a minute. So B vitamins, just did a whole big rave review for B vitamins. CoQ10, that comes into play at the bottom here, okay? When you're making energy, that's the final step down there in the electron transport chain. You have to have CoQ10. Lipoic acid, I just showed you. Magnesium is involved in every step. Chromium is involved obviously in glucose metabolism, and then antioxidants protect this whole thing. Antioxidants are like the shield or the protector. So if you think about this as your metabolism here, CoQ10 is important for this stage here. Magnesium is important for this step, and this step. You have to have magnesium for every step. The B vitamins are important for this step, and this step. You have to have the B vitamins for everything. CoQ10 is mostly down here, and then antioxidants protect this whole system from damage. And why do we want to do that? Because if this enzyme here, succinate dehydrogenase, gets damaged, then your whole metabolism breaks down. It doesn't work right. You know, it's like if someone had a bicycle, it'd be like breaking the chain on the bike and then saying, go ride that bike, and be like, whoa, I can't because the chain's broken. If you have a link that's broken in a pathway like this, then the pathway doesn't work. So you're metabolically compromised, let's say. Okay, here we go again. That's right out of Dr. Lord's book, Carb Metabolism. But I already said that, I showed that to you already, okay. And I want to stay on time here, so I'm going to skip some of these slides here. All these other slides here are just to say that like muscle is like super, super important, okay? If you don't have, well, I think the easiest way to think about it is that muscle is, if the person's not exercising and not strengthening their muscle, then there's no point in giving them these supplements. There really isn't. Now, if they're too fatigued to be able to exercise, use the supplements until they can start to exercise. But exercise is going to impact mitochondrial health. Exercise is going to impact fat burning or beta-oxidation. Exercise is going to impact glycolysis more than any other thing that you could possibly do. So beta-oxidation, which we talked a lot about, is related to zone 2 training. That's low intensity cardio. So, or moderate intensity cardio, 60 to 70% of your heart rate. So if you see a carnitine deficiency and a beta oxidation problem, you want to combine that carnitine with zone 2 training, okay? The Tour de France was just one, and they estimate that the winner of the Tour de France, and I think this is maybe true, as a cyclist, maybe it's a little biased, has the most healthy mitochondria on the planet. And what does he do for his training? It's like 80% zone 2 training. That's how you get mitochondria healthy. Now, does he only do that? No, because then he would get his ass kicked by all the other riders out there. So high intensity interval training is also important, little bits of that. That gets the high end, that gets that whole glucose to lactate thing working, right? Because when you do, and I just did this for 4 minutes this morning before I got on the call. That's why I'm kind of jacked up right now. I didn't have any coffee today, but I did 4 minutes on the rowing machine at high intensity, you know. And if you're wondering, my VO2 max is in the high 30s, but I want to get it into the 40s, but I haven't been able to do that yet. But anyways, high intensity training generates tons of lactate. And what did we just say 5 times? Lactate is a preferred fuel supply for your brain and your heart. So high intensity training has a very important benefit as well. And then you have to do resistance training and build muscle. That's where the mitochondria are. Okay, if you're trying to repair mitochondria and you're not building muscle, it doesn't make any sense. The only exception is if the patient's so exhausted they can't exercise yet. But the supplements without the exercise make no sense at all. And the muscle is the metabolic powerhouse. That's where everything's happening, okay, to make all this work. So you have to have that as part of the program. Okay. So for those of you that joined us late, we have a lab interpretation course coming up, an intensive with organic acids profile review from Diagnostic Solutions. This is a great class. People love it. You're going to learn a lot. You may cry a little bit, you may get frustrated, but you're going to learn tons and you'll be a better practitioner at the end of it. I was joking about crying and stuff. You're going to be happy. You're going to love it. Scan that QR code, sign up, and learn how to do this stuff. If you're not running organic acids on every single new patient, I'm just going to say it, you're not doing functional medicine. How can you do functional medicine and not check metabolic health? I mean, you just can't. You gotta, and I know I didn't run this test on every new patient for 20 years. I made that mistake for 20 years. Don't make that mistake. There's 20 years of patients that I could have helped way more if I had simply run this test. The cost is insignificant. Compared to the benefit, it's not even something to consider, okay? Run this test on everybody. If you start, and I've trained thousands of doctors in this idea. Once you start running this test on everybody, if you know how to interpret it, there's a big if. If you know how to interpret this thing and you run it on everybody, you will do that the rest of your career, I guarantee you, because once you see the importance of this, you will never look back, okay? All right, so now, and then someone's asking, do I have a course that covers the GI map and organic acids together? That would be our level 1 class does that, level 1 certification does that, but it's in separate modules, so you have to take them separately. Yeah, but it's all under level 1. If you want to do the level 1 certification, that would be all included in there. But there's not a single class that covers them both. But I'll just show you, since that question was asked here real quick. Let me just show you how we're set up here at the Kalish Institute. Thanks for asking that question. Here we have this bootcamp or this course coming up now, right, which is specifically on organic acids. Here, you can see that, interpreting organic acids from Diagnostic Solutions. Okay, and then that's coming up October 7th. That's what we're talking about today. And then we also have this level 1 certification where we have these protocol design intensives on organic acids, and then here's the GI. So you can combine these two together and end up getting the GI map and organic acids testing done together, okay? But it's separate courses. All right, keep asking questions and I'll come back to that question stuff in a minute. And let's see, let's pull up now some labs. So if you were actually in this course, taking this class, the paid class, not the free one, then you would be submitting labs. There'd be a session on a regular basis where we're reviewing all the labs, and you have lectures like I just gave where you can like listen to stuff, okay? But the most important part of this is looking at labs and learning how to interpret them. So now, here we go. This is a organic acids profile from Diagnostic Solutions here. And here's pyruvic acid and lactic acid. Let's focus on pyruvic acid for now. So pyruvic acid is high. What does that mean? That means that enzyme, pyruvate dehydrogenase, isn't working right. It's pyruvic acid's backing up. There's a backlog there. So what are you going to do? You're going to give the coenzyme, which is equally or perhaps even more important than the enzyme. It's not more important than the enzyme, but it's equally important. It even tells you the name of the enzyme right here. Look, see, pyruvate dehydrogenase. You don't have to memorize that. And then what are the nutrients that run that enzyme? Remember the picture I just showed you? There they are: thiamine, riboflavin, niacin, pantothenic acid, and lipoic acid. That's it. That's the solution. The solution is sitting right there. And you want the biochemistry behind it. We just looked at that. So then let's see what else is going on here. Pyruvic acid, that's high there. Oh, okay. Well, this is kind of unrelated to today's class, but we should cover it just because it's showing up. Here, this is also elevated. Homovanillinic, okay, and that's a dopamine-related marker. So this person's stressed, basically. or depressed. And then here we have oxidative stress. So oxidative stress, 8-OHDG, you want that below, well, officially you want that below like a 6.4. But Walter Crinian, who's really the leading expert on this back in the day before he died, he always taught me, it should be at a 4 or less. So realistically, you want 8-OHTG below a 4. So oxidative stress, why is that a problem? Because that enzyme is just sitting there in your mitochondria. Sitting there in your cell, it's outside the mitochondria, trying to make this conversion happen, and it's getting damaged from oxidative stress. And that's going to make the enzyme work even worse than it is now. Okay, so how do you fix all that? Do you see what I mean? I hope that made sense the way I said that. Okay, yeah, you guys will all, this Connie is asking, you guys will all get a link for the class in your email. So just check your email inbox. If you don't see it, it's probably because it went to spam. And let's see here. You can always just contact my office and we can get you a copy of the link. So now, lipoic acid. Every company sells this stuff. It usually comes in the 300 milligram capsule, sort of typical. And depending on your experience level, if you're just starting out, you're kind of new to this stuff, I would just start with like 1 twice a day. You can go a lot higher than that, but I wouldn't if this is like the first few times you've done this. And then, so here, we're trying to solve for balancing out pyruvate glycolysis. And then you want to use the B complex. So we talked B1, B2, B3, we talked about that, right? All the Bs. So a couple of B complex, usually 1 twice a day is enough for most people. And then you want to include your chromium. And most of the companies will have a combination blood sugar product, biotin. It'll have stuff like that in. Sometimes they'll have the cinnamon extract thing in it. But some kind of blood sugar stabilizing product, a couple of those. There. And that's enough to get that one marker fixed, okay? If it's not working, you can give some extra thiamine. And then they had a lot of oxidative stress also, so you want to use an antioxidant formula, some kind of combination antioxidant formula. Right, because you want to protect the enzymes from getting more damaged. That's the whole problem, is that the enzyme's damaged, and oxidative stress is going to make that even worse. Antioxidant. And you see how then once you become insulin resistant, that insulin resistance creates even more oxidative stress. So you need a combination antioxidant. And the ones that I like the most are CoQ10. A lot of times you use vitamin E. Vitamin C is like the classic one. You can use plant-based stuff. You have a ton of different options, but you want to spread, antioxidants throughout the system there. Okay. So that would be a basic. Oh, and this person had a problem with the brain, so they also needed tyrosine. That would calm them down and make them feel better too, okay? So this is alpha lipoic acid, or usually known as lipoic acid. Nothing fancy. All right. Okay, so that's lab 1. Oh, we got plenty of time. Look at us, right on time. If you sign up for this class, you're gonna be doing this, but with real labs that are like yours and your patients. It's fun. And we price these things. They're not very expensive for what you're getting. There's so much content in this thing. And at the end of this, you'll actually be better for real. It's not like some fake out class where, you know what I mean? Okay, what's happening with this one? Here. So now, here's the tricky part. This person could have the exact same symptoms as the last person. They could have brain fog, fatigue, be overweight, be pre-diabetic, could be brain fog, could be infertility. It doesn't really matter. They could have the exact same set of symptoms. And then you're thinking, oh, well, this must be insulin resistance because it sounds like it and they eat a lot of sugar. And then you run this test and you go, oh, well, actually, all the glycolysis markers, this whole section, they're all fine. Huh, that's strange. I can't tell you how many times this has happened to me. Like a lot of times this has happened because I'm very opinionated and I really am I'm a little arrogant. I come across maybe as not being arrogant, but I'm like secretly very arrogant. So I always think that what I think is right, you know. This happens even now, even though I'm like 61, if we're out, like this just happened in the drugstore, or not a drugstore, in like the hardware store. We walked into the hardware store and I'm just like a stupid guy in a movie. I'm like, no, I can find it. And then my wife is like, you're an idiot. And she just goes up, asks somebody where it is, and then she gets it like before I could find it. So anyways, I'm kind of a little bit of that personality, okay? And so that's the worst kind of thing to apply to functional medicine, because if I was sure that this person had a insulin resistance problem, I run the lab, I'm like, oh, nope. So what I've learned at work is to just be completely a blank slate. I don't have any personal opinions about anything with anybody until I see the labs. Nothing, because I've been wrong so many times. So many times I get the labs back. I'm like, wow, I was totally wrong. I don't even form opinions about this anymore. I'm just like neutral, and I see the lab. And but I would think if I saw this lab, I would think, oh, wow, that's surprising. I would have thought the person had a blood sugar related problem, but no, adipic acid, subearic acid are high. This is a beta oxidation problem. Ding, 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 ding. Okay, it's not an insulin problem. This happens a lot, okay? Like a lot. Enough that even if you're not arrogant, even if you're like really like self-effacing and think you're always wrong about everything, you're still going to get it wrong a lot because you can't tell just from talking to people. You have to do the lab. So adipic acid and subearic acid high. That means you've got a block at fatty acid oxidation. And you've got these four here: succinic acid, alpha-ketogluteric acid, isocyclic acid, and ciconic acid. These are all like sky high as well. Okay, so let's go look at that just for a second, because we didn't really talk too much about that, but I have a diagram on it right here. I gotta admit, this is kind of, I don't know if fun is the right word, but it's pretty interesting to see this. And when it's like a real human being and you thought that they had a glucose problem and you're wrong, you gotta use these labs to cover yourself. Being wrong with a patient is not acceptable, not if it's easy to figure out. Okay, so this person has, I think there's 4 of these enzymes here. These ones, I think it was cisaconate, alpha-ketoglutarate, succinate, and I forget the other one, but 4 of these were high. So what does that mean? That means the citric acid cycle itself is gunked up. So remember I used that example of like a bike chain with a broken link? This is like a bike chain with 4 broken links. This thing is not working. So how do you fix that? Well, you know already, I said magnesium, because magnesium is for all 3 of these. CoQ10, okay, is for this part and this part, and B vitamins. Okay, how much? And we can design a program in a second. And this person also had adipic acid and subearic acid high. That means there's a block here, and they need carnitine. So here, let's go. Why? Somebody is asking, why do people have these problems? You know, it could be diet related, it could be environmental toxin related, or it could be genetic. So in other words, let's just pick on this one because it's my favorite. Succinic acid, succinate dehydrogenase. This enzyme could be nuked because it got oxidatively stressed, you know, and a pro-oxidant thing hit it, didn't have enough protection from antioxidants. That would do it. That could be an environmental toxin. Not a good thing. You could have a genetic issue. You could be prone to this kind of a problem. That's most common with beta oxidation. A lot of people have genetically based long chain fatty acid disorders. It means that their beta oxidation screwed up. It's just the way they were born. You could eat your way into this if you ate enough carbohydrate and you avoided vegetables for long enough. If you're running these energy cycles and you don't have the antioxidant protection, that's like eating bad food without a lot of antioxidants in it, no fruits, no vegetables, then that could cause it too. So there's lots of different reasons why this could happen. And some of these markers are more typically genetically based. Like the one that is almost always genetically based is the carnitine thing. All right, oh no, sorry, I'm in the wrong thing here. I need to go over here. So now let's see what else is on this report, and then we'll design one more program, and then I'll go for questions. Let's see. Oh, well, that's convenient here. these markers here, this is confusing. When these markers go high, it means there's a B vitamin deficiency. B vitamin deficiency, that's counterintuitive. You think if they were low, it means there's a B vitamin. Anyways, if these are high, there's a block and there's a B vitamin deficiency. This is a super important one, methylmalonic acid. If that's high, you have a B12 deficiency. And this one is equally important. If it's high, you have a folate deficiency. And this one's even more important. If it's high, you have a B6 deficiency. So this is like the poster child person for a methylation defect. They have high methylmalonic acid, that's a B12 deficiency, high FIGLU, that's a folate deficiency, and high xanthranic acid, that's a B6 problem. Yikes. We had a case just like this in class this morning. If any of my mentorship students are on the call, you guys might remember that. This is real stuff. This happens to real people all the time. Okay, that's probably enough to think about, right? I don't want to confuse everybody. So let's design a program. And we're trying to keep this simple. This is, this is not enough for you to be like the best doctor in the world, but this is enough for you to get excited, sign up for the class on the OAP, and then by the end of the class, at least you'll have a good introduction and you'll understand way better what to do. So you can use carnitine. You have to use carnitine with this person. And let's say it's in a 340 milligram, that's the one that I use. You can get carnitine from lots of companies. You don't need the acetyl L-carnitine. That's usually used for brain. Just plain old L-carnitine. It's a fraction of the price and it works just as well. If you have a brain problem, that's different. So how much carnitine? You need about 2 grams of it. Well, this would be nice here. It can cause diarrhea, so be careful. Ease the person onto it. And then B vitamins, we know that because we know that you need B vitamins for every one of these programs. This person kind of extra needed CoQ10, remember that? Because those citric acid cycle markers were screwed up. I use a 200 milligram version of it. And then you always got to give magnesium because all these people need magnesium. Whatever form of magnesium you like. I like the glycinate, but you can use whatever you like. And then, did I miss something? Let's see. Here. That's probably enough on the factoids. Yeah, so we're covering basically glycolysis was fine. They don't have the insulin problem. We're surprised. Krebs cycle or citric acid cycle is screwed up. CoQ10, magnesium, B vitamins. Fatty acid oxidation is the main problem in energy production here in terms of glycolysis versus beta oxidation. So we're going to use the carnitine. This program would work. And then some kind of a multivitamin to make everything happen. And this program is pretty different than the one I just designed a second ago, right? And this program wouldn't help the other person very much. And the other person's program without the carnitine is not going to. I mean, if you gave the blood sugar person this program, it would help, yeah, a lot, but it wouldn't like target it. And if you took the carnitine person and you put them on all the blood sugar support, it's not going to solve the beta oxidation thing. Not even a little bit. Can I just show you why? Like, and this is not like my personal opinion. We're stuck with this basic physiology. It's just pathways. There's no relationship here. No, actually, I mean, remember, here's our carnitine. This is like the most important thing to learn today is that carnitine is pretty darn important. And here's my favorite drawing, right? So that carnitine is the only thing that can do this beta oxidation trip here. You can't cram a B vitamin on here. You can't, I mean, B vitamins are involved in this, of course. B2 is the one that's mostly involved in this. And there's your CoA, so B5 is involved. The B vitamins are involved. But if you don't have carnitine, this is not going to work. So if you see those high markers under beta oxidation, you have to use carnitine, or it's just not going to have an effect. There's a whole different mechanism than glycolysis. It's happening in a whole different way with a whole bunch of different pathways. I mean, honestly, they're almost completely unrelated, other than that they're both, how you make energy. But from like the pathway perspective, they're very, very different. You're not going to fix the one without the other. Okay, here. So I'm going to put this on the screen so you guys can all sign up. If you really want to learn how to do this, sign up for this class. Get it in before the year is over, starting October 7th. All right, so now we got a few minutes left. I'm exactly on time, which is frightening. So type in any questions that you have, and we'll go over them. And it could be literally about anything. Somebody got the coconut question right. A couple of people did. That's great. So that you can medium chain fats can get into the mitochondria without the shuttle there. So if you're living on coconut oil, you're going to be just fine. Let's see here. We talked about that. So then somebody's asking a question about, yeah, for sure. If you have a kid you can do this testing on children. I wouldn't do it on a 2-year-old, but I don't know. Let's say age 10 and above, once kids are getting a little bit bigger. You can definitely do this test on children. I've done that frequently as a regular part of my practice. Oh, Connie's asking, yeah, everything is recorded. So if you sign up for this class, all the live calls are recorded. The curriculum is all posted online. And also, I set up a live one-on-one call with each student who's in this course. So even if you're like a little bit off schedule, it sounds like Connie has a conference or something, we'll still get a chance for you and I to speak one-on-one, get your practice oriented around organic acids testing, and then you can listen to all the recordings if you miss the first session or two or something, okay? Do I have a preference for OAP versus omics? Yeah, kind of. Have you ever been in a Lamborghini? I was in a Lamborghini once, and a friend of mine who's a doctor, a functional medicine doctor named Frank, he thought this would be fun. So he took me to his friend who ran a Lamborghini dealership. And Frank's like, would you let Dan get in the car? He didn't let me drive the car. He just let me sit in it. And the guy's like, okay, we'll let Dan get in the car. So I get in this Lamborghini, and this guy's like, "Rrr." It was like the worst experience of my life. I almost threw up. The thing was going so fast. But is a Lamborghini a great car? Yeah, but that's like the omics test, okay? Like the OAP, the organic acids profile, that's like your Honda, that's like your Toyota, it's like your Mercedes, it's like your Volvo. Use the OAP, just master the OAP, get it down, figure it out. When you're like ready to escalate and you just want to go 200 miles an hour, then start to order the omics test, okay? This is for Christy. So the omics test, is it a great test? Yeah. Is the Lamborghini a great car? Yeah. Is it going to help you when you're just learning how to do this? No, no. That's why that guy wouldn't let me drive the Lamborghini. He knew I would have crashed it. If I hit the gas on a turn, I would have probably crashed this $200,000 car, $600,000 car, whatever it was. So the omics is a beautiful, well-designed, intense test, but it's a little too much for the first couple years of practice. It takes me at least 2 years to really fully train a doctor in this test that we're looking at today. Well, let's not exaggerate. A year. It takes at least a year to get you fully trained in this test that we're looking at. And once you're at that level, if you put in full-time work and really study it, then you can do the omics later. But what overwhelms people if they do the omics too early, it's just too much, and you'll get disillusioned about it all. Okay. What's the best combination test? So in all patient workups and all the classes that I teach, we talk about on the first set of tests or 3 labs: adrenal hormones and other hormones, GI map, and the OAP. So every patient gets an adrenal lab, GI map, and OAP. That's the basic workup in my world. Yeah, for sure. Erica's asking about women exercising in a fasted state. Of course, yeah, for sure, can do that. So carnitine, again, it's L-carnitine, and you want to be at around 2,000 a day if they have a problem like that. But it can cause diarrhea, so ease people onto it. Talked about lipoic acid. Let's see. If CoQ10 is high on a test, it usually means that the person is taking it. Um, let's see here. let's see, I think I answered most of these already. What if glycolysis markers are very low? That makes you wonder, doesn't it? It depends on the pattern, right? Because pyruvate and lactate go back and forth to each other. So it depends on the pattern. But you can have one that's high and the other that's low. They can be in the reverse and they can be both low. Any of those patterns are not good. Okay, it means there's a block there, but it's a little more complicated than what we're talking about today. Yeah, so let's see. And this is all symptom independent. So you can have the exact same carnitine deficiency problem in someone who's overweight and someone that has had a recent heart attack and someone that just has chronic fatigue, someone that has a thyroid problem. And by the way, carnitine is contraindicated if they have thyroid, if they're on thyroid medications. You have to be careful about that. Why would there be normal B vitamin levels with high beta oxidation markers? Yeah, that's not unusual. You can definitely have that. Those are somewhat independent variables for Kristen there. If pyruvate is high, yeah, you don't necessarily need carnitine if pyruvate is high. Carnitine is only needed for the beta oxidation people. If only one is high, so this is Susan asking, if only adipic acid is high and subearic is not, you still give the carnitine. They don't all have to be high, just one being high is enough. I use pure encapsulations carnitine or designs for health carnitine, kind of depending on who's in stock on Fullscript, to be honest. I like the carnitine from designs a little bit more. I think it's a little cheaper, but it works. Let's see. Patrick is asking, if you have a carnitine issue, not a glucose pathway, can you still have a high A1C? Shouldn't. It's a good question, though. I'm not sure about that. I'm not sure. Intuitively, I would say probably not. But as I mentioned earlier, I'm wrong most of the time. So I'm not sure about that one, Patrick. Don't trust my personal opinions on things. Do you ever run this test and not find any problems? Yeah, totally. We do that all the time. In fact, we have doctors in my mentorship class. This just happened recently. This doctor submitted her own test and it was perfect. And guess what? Her microbiome, her GI map was perfect too. I was freaking out. I was like, what is going on in your life? And I was like, what? And she grows all her own food. Well, that'll help. She's got like a little farm in her backyard. She grows all her own produce. She exercises every day. She has a great relationship. And her microbiome was perfect. Her whole GI map was like, there was nothing wrong with it. And her organic acids test was beautiful. It was just like sunny and beautiful. It was like a day at the beach. And I talked with her for a while in class because I wanted all the students to hear, like, you got to earn this stuff. But if you grow your own food and you eat fresh organic food and you're clean with your diet and you have loving relationships with other human beings and the world around you, and you eat a lot of vegetables and fruit, you should have a perfect GI map and a perfect organic acids. And the fact, who's asking that question? The fact that you're even asking that question, it's Christy. But it's a good question. Why? Because we could go for months in my different coursework and not see a normal test. That's how screwed up people are. Okay, that's how screwed up. So organic acids testing. Yeah, so Diagnostic Solutions is for sure the go-to lab for this test. You don't have to wait to, you can start supplementing at the beginning of a program. Of course, you want to do the lifestyle at the same time too, okay? Someone with a SNP need to take carnitine on a regular basis? Maybe yes, maybe not, depending on how bad the genetic defect is. Mostly not. I think most of the time people, if you get their carnitine levels up for a while, then you're okay. We don't do any CME type things in the courses because the courses talk specifically about brands. And I tell you, use the Diagnostic Solutions GI map test, use the Diagnostic Solutions OAP, get the designs for health, carnitine, synergy stuff. So we're not able to do any CE credit because we have mentioning brand names constantly. If the high meat markers are high, it means the person's eating meat. Doesn't mean anything bad is happening. When you're taking the test, yeah, you should have people stop their nutrients for like a week before they do the test in general. So if there's high lactate, it's the same exact solution. Okay, same exact solution as high pyruvate. There's no difference. The treatments are identical. Let's see here. I think we're running out of time. Are we? Oh, yeah, we're out of time. Okay, I hope this was helpful, you guys. Thank you so much for asking all these questions, and I'm looking forward to joining some of you in this course. Okay? All right, take care now. Bye for now.